This is a continuation video from the video that started with the section. It's section 2 of your Unit 3 quadratic functions flipbook, section 2, bottom flap. We've already defined parabola, vertex, axis of symmetry, y-intercept, and x-intercept. Let's go ahead now and go through the rest of them. So first we'll talk about minimum and maximum. I'm going to change colors now here. Minimum and maximum. So when we talk about minimum, we're really talking about the lowest part of the parabola. So a minimum value only makes sense when the graph of the parabola faces up. So when the parabola, and I'm going to say opens up, and let's go ahead and draw that when it looks like this. Okay, when it opens up, then the vertex is the minimum. And let's be a little bit more specific. Then the y value of the vertex is the minimum. Minimum value. And think about that, makes sense. It's going to be the lowest point on the graph, so it's going to be the smallest y value. If you look at this graph, this vertex right here, that's as low as the parabola goes. Once it gets to the vertex, it starts going back up the other way. So the vertex is the lowest point of the parabola. We call that the minimum point, and the minimum is defined as the y value. Okay, then the y value of the vertex is the minimum value, and the opposite is going to apply over here. If I ask you about the maximum of a graph, that only makes sense if the parabola is facing down or opening down. So for maximum, we're going to say basically the same definition, just change a couple words. When the parabola opens down, and that means its shape looks like this. Make that kind of a little shape, okay? Then the y value of the vertex is the maximum value. Think about these in real life. If this was a graph that talked about the height of, let's say we threw a football in the air, and this is graphing the height of the football over time, the vertex would be the maximum height of that particular football. It would have the maximum value. The y value at the vertex would be the maximum. And if this was a graph that showed the depth of a submarine as it's descending underwater over time, if we look at that parabola, if the submarine dives and comes up in the shape of a parabola, the vertex here would be defining what is the lowest depth or the minimum depth that that submarine reaches before it begins to come back up and surface. So there's our definition of maximum and minimum. Here's the last thing we'll talk about, and that is domain and range. And you've covered domain and range in Integrated Math 1. If you want to recall here, the domain is all the possible x values. So all possible x values. So the set of all possible x values. And take a look at the graph here. Now what I want you to notice is it looks like eventually these arrows on a parabola will start going straight up, but they never will, class. As those arrows continue on into infinity, they will continue to get wider and wider and wider and wider. If we made a massive parabola, those arrows just keep on moving out. Those points would move farther and farther apart. So for any parabola, the domain is always the set of all real numbers. So the domain for a parabola, so let's put for a parabola, it is the set of all real numbers. So no matter what kind of equation we have, what kind of quadratic we have, our x values can be anything. Can be a billion, positive billion, negative billion, larger than that, anything. Every x value will be represented on any parabola. The bigger the parabola goes, the more you'll see the arrows just keep expanding further and further out, and they will expand out on the x-axis to infinity in both directions. Let's take a look at range. What is range? The range is all the possible y values. And this one's different than the domain. So all possible y values. Now take a look at our two graphs. If the parabola is facing up or opening up, it's going to be every y value starting from the vertex and going up. The only y values that aren't represented on this graph are all the y values that are below the vertex. If the parabola is opening down, we have the opposite effect. The range is all the points starting with the vertex and continuing down infinitely in the negative direction. These arrows will keep going down. These arrows will keep going up. So the range depends on which way the parabola faces and where the vertex is. So if we put on here, well, let's make a note here. If the parabola is facing up, I'm just going to use a little symbol. If the parabola is facing up, use those little two arrows to say parabola is facing up, it's going to be all numbers that are, I'll just use math symbol, all numbers that are greater than or equal to the y value of the vertex. And that makes sense. Take a look at our graph. Yep, all of our possible y values starting from the vertex. Our vertex is at y equals -3, so it's going to be -3 and everything greater than -3. So if our parabola now has the opposite shape, if our parabola faces down or opens down, hang on a second, I got a little electronic delay here, there we go. If the parabola opens down, then our range is going to be all numbers that are less than or equal to the y value of the vertex. Let's take a look at that with our downward facing example. Here is a parabola that opens down. Our maximum y value is going to be 1, 2, 3, 4, so it's y equals 4, and our possible y values will be 4 and everything less than 4. So there is our definition of domain and range. Make sure you are familiar with and know these words. You don't have to know the exact definition, but when we're using these words in class, you need to understand what we are talking about when we use words like parabola, domain, axis of symmetry, and the rest of them.